the two Weber problems. So the two that we should talk about are the ones I give you hints on. So this first one, oh, is it this? Yeah, number one. Okay, so the first one, so the first thing they're asking for is dy dx, okay? And dy dx is not the same as dy dt, but dy dt is part of it. So given dy dt, then how do we find dy dx? Okay, ready to start? Okay, so we know that dy dx is different than dy dt, right? Dy dx is about how much y changes for a change in x. Dy dt is about how much y changes for a change in t. And those are different. Those are different derivatives. So if we want dy dx and we got everything's in terms of t, then we're going to divide dy dt by dx dt. And so then it's going to be 4 minus 1 over t, that's dy dt, over dx dt is 2 plus 1 over t. And then my hint to you on announcements was, before we go any farther here, let's multiply top and bottom. We can do this, right? We can multiply top and bottom by t because that's like multiplying by 1. It doesn't change it. So then this is equivalent to 4t minus 1 over 2t plus 1, and that's going to be a lot easier to work with. Okay, so the same thing now applies to the second derivative, that derivative of dy dx with respect to x is not equal to the derivative of dy dx with respect to t. Those are two different things. How much our first derivative changes for a little change in x is different than how much the derivative changes for a little change in t. But we've got this derivative in terms of t, so we're going to be calculating this. Okay, we're going to be calculating this with respect to t because our derivative is, our dy dx is in terms of t. So when we take the derivative of this, we'll be finding it with respect to t, and what we need is with respect to x. So what are we going to do? Same thing. We've got it with respect to t, we want it with respect to x. So this thing will equal I'm not done yet. How do I make it? How do I use this now to find that dy, the derivative of the derivative with respect to x? Well, no, that's the this. I'm asking about this. I'm asking about how do I find this? No, I mean, kinda. It's the same thing. It's why I went through all the pain of telling you this, right? It's the same thing. If you have it with respect to t, but you want it with respect to x, what do you do? Divide by dx dt. Were you all thinking it and just not saying anything, or? It's the same thing. It's the same thing. So how are we going to find that with respect to t? That'll be the quotient rule. And then we're going to divide by dx dt, which we already found. Dx dt is 2 plus 1 over t. So you're going to do the quotient rule on that. And you're going to divide by 2 plus 1 over t, and that'll give you the second derivative with respect to x. Do I need to do it? Or does that clear it up for those who struggled? Is it cleared up? Any questions? Where's everybody today? Quick, take attendance. Give these people some credit. Okay. Last chance. Questions on this one? Yes, please. Because do you see that this is not the same as this? So we have the first derivative dy dx with respect to t. So if we're going to differentiate that, what we're getting is that. We're getting the derivative of the derivative, but for a change in t, if our variable is t. That's not what's being asked for. What's being asked for is the derivative with respect to x. Okay, so just like up there, what did we do to get from dy dt to dy dx? Divided by dx dt, same thing. What do we get d something dt to get d? What do we divide by to get d something dt to get d something dx? Divided by dx dt. Is it better? Yeah. So it's the exact same pattern as this up here. This does equal, the way I changed it does equal that now. That is equal. So the moral of the story is, if you have the derivative you need with respect to t, and you need it with respect to x, then you can divide by dx dt, and that gets you what you want. If you have it with respect to t and you want it with respect to x, divide by dx dt. It's the same thing in both cases. Okay, are we good? All right, let's do the area one. So I also gave you some suggestion here, or some hint on this one. And I told you that the way this picture looks is something like this. And they want the area between the curves. And so, when we do these areas in parametric equations, I really tried to emphasize on Wednesday that we're doing it the exact same way, and then we're just going to transform that integral in terms of t. So we're thinking about these the way we thought about them before. And what was that? Typical strip, right? Okay, and so we want the area of a typical strip. So what is the area of a typical strip there? Y times the change in x. Agree with that? So this is a change, right? The height, so it's base times height. And the base is going to be delta x. The height is going to be a change in y, right? Now it's going to be a change in y. And so our integral will be from, say, this is x1. So what will our integral be? From x1 to x2 of y2 minus y1 dx. Okay, so that's what we're going to do. So we do the same way we did before, but now we need to take our parametric function and rewrite this, change the variables, right? So rather than being in the variable x, we need to change it to the variable t. But it's going to have this structure. It's going to have the same structure for the problems that we did before. So what do we need? For the limits of integration, we're going to need these points. And more specifically, we're going to need the t values for those intersection points, right? We need the t value corresponding to x1 and the t value corresponding to x2. Okay? And then we're going to do y2 minus y1. What's y2 in my problem? 5/2. What's y1? T plus 1 over t. And then what is dx? So we saw that before. Dx is going to be, dx is going to be the derivative of x with respect to t times dt. So it's going to be 1, that ends up being plus 1 over t squared. Is that right? dt. So all that's left now is to get those limits of integration. Again, it's the same, it's just following the exact structure of how we did it back in January, but then rewriting the integral in terms of t. Okay, so how do we get t1 and t2? How do we get these starting and end points? Well, what's true about this? X's are the same and y's are the same. So we want to know when y equals what? 5/2. Where does y equal 5/2? And that will be, so if we multiply by t, we get a quadratic. We get t squared. Let's multiply by 2t. So 2t squared minus 5t plus 2 equals 0. So what did I do? I multiplied by t, and I multiplied by 2, and I subtracted this term over here. And you get this quadratic. And that gives you two values of t. 2t looks like minus 2 minus 1. So t equals 1/2, and t equals 2. So all based on this. We just want to know the t value, so we don't have to worry about x. We just need the t value for which that y is 5/2. And that gives me the t values of those 2 points. Now, what do I have to make sure about? I have to make sure, so what I don't know is what? Which is the 1/2. So you can't just assume that the lower t value is giving you the lower x value. That's not necessarily true. So we have to check it, because we need this to be specifically that this is t1. t1 has to get me that point, and t2 has to get me that point. So which one is which? So we can use x. So let's put 2 in. That's easy. So 2 minus 1/2. This is this one, right? So this is t2 is 2, and t1 is 1/2. So we're going to integrate from 1/2 to 2. And then you just need to multiply out carefully, and you have an easy antiderivative, and use the fundamental theorem to evaluate. I went fast. Any questions? Did I lose you? But this is the main. So there's some algebra here. But that shouldn't have been anything new. But this is the key to these. That we're going to approach these areas just like we approached areas before, and then we're going to just change the variable to t. Change the variable to t. And we know when we do dx, it's the derivative of x dt. Okay. Any questions? Does it help? Okay, so we're going to move on to the next section. So you've got your Clara project, which is going to apply most everything we learned in this parametric section. And parametric functions is one of, if not the most important thing for Calc 3 that comes from this course, okay? Parametric functions is a huge concept which actually kind of manifests itself as vector functions, right? So we're going to do a lot of vectors in Calc 3. Vector functions are they're like the twin of parametric functions. They're almost exactly the same thing. So this stuff is really important. So get started on the Clara project. Do not wait a week and save yourself 2 days for it. Okay? It is definitely doable, but it's challenging. You're going to need some time to work on it and maybe get some help. Read carefully. Don't cruise through it without being sure about what you've done before. Okay? Any questions? Okay, so let's see here. Polar coordinates. Polar coordinates is a whole new way of organizing the plane. It's a whole new way of organizing the plane. How have we organized it so far? How do we graph things? It's called rectangular coordinates, right? Rectangular coordinates.
I was going to say with
X and Y. What does X mean? What does the X coordinate mean? How far left or right, right? So if it's positive, it's distance to the right of the y-axis. If it's negative, distance to the left of the y-axis. Similarly, y-coordinate is your up and down coordinate, right? Distance up from the x-axis or distance down. Okay? So the polar plane, totally different, okay? Polar coordinates are based on the distance from the pole, which is a new name for the origin. So it's kind of like you're looking down on the top of the Earth at the North Pole, right? And then these are the latitude lines, right? So these are like the latitude lines. And so imagine you're looking down at the top of the world, and so the origin we call the pole. And then, as a function of angle theta, which is our standard trig angle. Okay, our standard trig angle is the angle swept, counterclockwise from the positive x-axis. Okay, so instead of using coordinates x and y, we use coordinates there we go. Okay, so instead of using coordinates x and y, we use coordinates theta, which is our standard trig angle, swept counterclockwise from the positive x-axis. Okay. And then r. So r is the distance from the pole. So this is an r of 3.5. So theta can be in any unit, could be in radians, degrees, doesn't matter. Usually we're going to work in radians mostly. Okay, and then so you sweep an angle counterclockwise from the 3 o'clock position, just like the standard trig angle we've seen before. And then along that line of the terminal ray of the angle, you have the distance from the pole. So in this case, r is 3.5. So this is the point. 3.5, comma, and suppose that is, I don't know, let's see. Just suppose it's pi over 8, okay? Just making it up. It's not, but it's 0.33 radians, okay? So just say pi over 8. All right, so what's kind of, you have to make note of is that the conventional way to organize the coordinate pairs is backwards, because you really want to think of theta first. Theta is like independent. You start with theta, and then once your theta is set, then you decide how far you're going to go from the pole, so then r is like dependent on theta. But then when you write ordered pairs, you write them r theta. So just be aware of that it's kind of backwards for how we think of independent and dependent, right? So theta is more thought of as the independent variable and r the dependent variable. But when you list an ordered pair, you listed r comma theta. Okay, so now notice that when you sweep this angle, theta, this is the direction of positive r, or r greater than 0. The black ray, right? What would r less than 0 for the same angle mean? What would r less than 0 for the same angle mean? Going the opposite direction, where I have the red ray. So the red ray would be for values of r less than 0. So what is the positive could be in any direction, because theta is determining the direction of where positive is. So positive being to the right and positive being up is totally off the table now. Positive is the direction of the terminal ray after you sweep the angle. And that can be in any quadrant, right? That can be in any quadrant. So this point right here would have coordinates what? What would r be? Not negative 3.5 anymore. Negative 2, right? It's on the circle of radius 2. So see, all the points on the circle of radius 2 have an r of 2. So r is like radius, right? R is like radius. So this would be now negative 2. And what would the angle be? Negative pi over 8? Still positive pi over 8. It's for positive pi over 8, these are the negative values of r in the opposite direction. So it's still positive pi over 8. Where would negative pi over 8 for an angle point? it would point into the fourth quadrant. So if it was negative pi over 8, your direction of positive r would be here. So this would be positive r for theta equals negative pi over 8. And then where would negative r values for that angle be? In the second quadrant. Do you see? So this point would be, according to this angle, would be what? Negative pi over 8. Sorry, r first. R would be negative 4. So would that be the only way to express that point then? So if I want this point in the plane, is negative 4 or negative pi over 8 the only way to express it? What would be another way? So there'd be another way to express that point. Yeah. Say it again. Okay. So if we wanted a positive angle to get us there, we could take, do it in blue. What angle would that be right there? What angle would that be that would give us this, go along this same trajectory as what, negative pi over 8? It would be, he said, pi minus pi over 8, or 7 pi over 8, right? And then what would the value of r be to get that point? Negative 4? Positive 4, right? Because if we go 7 pi over 8, now this is the black. This is positive values of r. And so it would be positive 4. Are those the only two ways to express that point? How many ways would there be to express that point? 2 more? Yeah, so there's no restriction on theta. It's not necessarily from 0 to 2 pi or 0 to negative 2 pi. Infinite ways. All I'd have to do is keep adding 2 pi to this, or adding 2 pi to this, or subtracting 2 pi. Or, so add or subtract 2 pi to 7 pi over 8 as many times as you want with positive 4. Add or subtract 2 pi as many times as you want it to negative pi over 8. And then use negative 4. So there's an infinite number of ways. Unlike rectangular coordinates, given a point in the plane, there's an infinite number of ways to express it. Okay? Yeah. Okay, yeah, we're getting there. Yeah, that's the right question. Right question. Okay, so that's just kind of a warm-up there for how it works with points, okay? How it works with points. So we talked about theta being more like independent and r being dependent. So these are the functions that you get. You get the polar curves have the functions r as a function of theta. Okay? R as a function of theta is what polar curves have. So our formulas are going to look like this. Here's a function of theta. E to the sine theta minus 2 cosine 4 theta. E to the sine theta. So that's a really complicated function, but it's kind of a fun one to start with. And so I'm going to show you how it gets traced out. So notice here at theta equals 0, what's the value of r? Negative 1. For theta equals 0, points along that positive x-axis. When theta equals 0, r is negative 1, so there's your first point, right there. As theta increases then, for every new theta, we get a new point. And when you graph all those points, you get a curve. So that's what you get when you change theta from 0 to pi over 2. That's all the values of r you get for those corresponding angles. Okay? And if we keep going here, and we go to 2 pi, That's the curve we get. Now, they're not all insects, okay? But this is a cool one to start with. So, but the idea is that as you increase theta, r changes. And so that sweeps out a locus of points that gives you a curve. And so with this kind of more complicated function, you get this butterfly. See it again? So here's 0 to pi over 2 and all the r values. Pi over 2 to pi. Pi to 3 pi over 2. And then 3 pi over 2 to 2 pi. Those are all the correspondence points of theta and r as theta goes from 0 to 2 pi. Okay, so Kaylin asked the right question. What about the relationship of rectangular coordinates to polar coordinates? So let's take a look here. Let's do theta is pi over 4. So here's theta at pi over 4. And let's pretend that point is at 4. Okay? So in polar coordinates, this is the point 4 pi over 4. Right? R comma theta. R comma theta. So how would we write that point in rectangular coordinates? What does the x coordinate of that point mean? What does the x coordinate of that point mean? Where is Sopwadi? Sopwadi here? Sopawati? I know she's here. Catherine, tell me about the x coordinate. What does it mean? If I want the x coordinate of that point, what's it about? Okay. The x coordinate is this. So that's actually what you said is it's r, right? R is different than x, right? So x is still the same x that we had before. That's r now. So you're talking about r equals 4. So what does x, the old school x that you've been dealing with all your life mean? Hold on a second. Right. Yeah, so how far horizontally is. So we could say that that's here. Or we could come down here and we'd say it's down here. So that's our x coordinate of this point. And then y coordinate. Is that. And remember, this is theta here. Pi over 4. So you should start to get an idea here of how we might find x and y. Is that a question? Okay, let me see. So we've got this angle theta. And then we got the x coordinate. How are we going to find the x coordinate of that? I know these two guys know. I know he knows. Yes, ma'am. Okay, it's going to have to do with cosine, right? So we got a right triangle. This is like trig, right? This is trig. And so is x cosine theta? So cosine theta would be if we considered the circle of radius 4 as just a circle of radius 1, right? If it was just like, and that would be how many radius lengths over we are, right? That'd be what fraction of a radius length we are. So if we want to get it in our units on the scale, then what else do we need? Times 4. So actually 4 cosine, we know what theta is. What is it? Pi over 4. So the x coordinate is 4 cosine pi over 4. And then as xy. It would be 4 cos pi over 4. And then you could all just recite to me for sine pi over 4, not even worth asking. Because what? Sine is the y-coordinate in terms of radius length. So what fraction of a radius up are we? And then to get it in the units of the axis, we multiply by 4. Okay, so just for practice, can you write that point in 2 more ways? Just so in polar coordinates. Write 2 more polar coordinates that'll get us the same point that we're talking about. 2 more sets of polar coordinates. Okay, where's Michael Walker? How'd it go? Did you get one? 3 pi over 4. So he wants negative 4, 3 pi over 4. Does it work? So it's the right idea. Where does 3 pi over 4 put you? So pi over 4, 2 pi over 4, 3 pi over 4 puts you in the second quadrant. So you mean instead 3 pi over 4, 4 pi over 4. You meant, yeah, so you're probably thinking this angle, right? But that's not 3 over pi over 4, that's 5 pi over 4. So we want negative 4 and 5 pi over 4. Does it work? Yeah, because if you're 5 pi over 4 points, positive r then points down into the third quadrant. So negative r will be back up in the first quadrant for the angle 5 pi over 4. Remember the angle, so here's the key. The angle measure is indicating the direction of positive r, and that could be in any direction. Negative r is in the exact opposite direction. So you got to get out of your mind, positive is up here or positive's over here. Positive can be in any direction. That's what theta is telling you. Theta is telling you the direction of positive r. Volunteer for another possibility. Griffin. Negative 4 and negative 3 pi over 4. Does it work? Yep. Negative 3 pi over 4 also puts you as the positive direction of r down here. Okay, so negative 3 pi over 4 means that positive r is this way, so negative r would be back this way. So there are others. There are others. Does it make sense? Okay, so then what about in general then? Any questions? Can I erase? So in general, if I've got any point, I want that one right there. I don't like any of these. That's fine. Okay, so this is any point r comma theta. What is the x-coordinate? And what is the y-coordinate of that point? X would be r cosine theta. Y would be r sine theta. So that would be what? You have the polar coordinates, you want the rectangular coordinates. So given a point, how many sets of rectangular coordinates? How many ways can we write this point in rectangular coordinates? Infinite number of ways? No, it only has one only has one distance from the y-axis. There's only one x-coordinate of that point, and there's only one y-coordinate at that point. So in rectangular coordinates, a given point only has one ordered pair. But a given point in the polar plane has, or in polar coordinates, has an infinite number of polar coordinates that could express that point. So keep that in mind. All right, so now what if we were given this as xy, and we wanted to find r and theta? So we have x and y, and we don't know r and theta. What does r equal, and what does theta equal? So this is r. How are we going to get r from x? We have x and y, we want r. How are we going to do it? It's your favorite formula in all of math. Right, we got a right triangle, we got x, we got y. R is going to be square root x squared plus y squared. Pythagorean theorem, right? And what about theta given x and y? How does theta relate to x and y? Through what relationship? How does theta relate to x and y? Through what relationship? Tangent, right? This y is the opposite side, x is the adjacent side. So tangent of theta equals y over x, therefore theta is inverse tangent, arctangent of y over x. Now, arctangent only gives you angles between, so the dependent variable of the arctangent function only will spit out an angle between negative pi over 2 and pi over 2. So, like we've seen in the past, like you've seen in calculus, with those inverse trig functions, you have to know what you're doing. You may have to adjust, add pi, subtract pi, add 2, make an adjustment to get the actual angle you want. Because if your angle is, outside of the range of negative pi over 2 to pi, arctangent is going to give you exactly the right angle. You're going to have to adjust it with multiples of pi or subtracting or something like that. Okay, so watch out for that. Okay, so let's have you practice. So that's relating, given r and theta, how you get x and y, given x and y, how you would get r and theta. All right? But the formulas are not the punchline. Understanding polar coordinates is the punchline, right? So if you just find yourself blindly using formulas, watch out, okay? You may get in trouble. You need to really understand polar coordinates. So let's have you practice a little bit here. So in number 1, this is what I'm saying. Don't just blindly plug into formulas. Think about what you're dealing with. So you're going to plot each point, and then you're going to find them in rectangular coordinates in the easiest way possible. And sometimes the easiest way possible is thinking and understanding, not formulas. Okay? And then plot the point for negative 7 pi over 6. Express as x and y. Caitlin, so what about 1 pi? Tell me. Okay, and tell me how you found that. Or you just look at it, right? You just look at it, right? So it gets you that point. Do you need the formulas? That's what I was talking about. You just understand that, oh, that's on the negative x-axis at negative 1, and I know the rectangular coordinates of that, which is negative 1, 0. Okay. Next one. Bing you. Yang. So negative 2 pi over 3, what quadrant is that in? What quadrant does that point into? I'm asking for the answer. I'm asking what quadrant does that point into? Negative 2 pi over 3. Fourth quadrant? He's saying that that will point into the fourth quadrant. Agree? Yep, he's right. It'll point right here. This is the angle negative 2 pi over 3. Third, I'm sorry, third. Is that? Yeah, third. Sorry, we were both thinking this quadrant, but I said fourth. Okay. So yeah, this points into the third quadrant. So this is the direction now. Once you pick that angle, that's the direction of positive r. That's the direction of positive r. Positive now is in that direction. Everything about that feels negative, right? But if you sweep to that angle, negative 2 pi over 3, now positive values of r go in that direction of the terminal ray of that angle. So we want 4. It's off my screen. Down here. Is that right? No, it's 2. But wait, this is negative 2. No. R equals 2 is in this direction. It's positive 2 is in this direction. There's the point right there. 2, negative 2 pi over 3. And then he said to get the x coordinate, it'll be 2 times cosine of that, 2 times sine of that. Cosine is that, so x is negative 1, and y is radical 3, negative. Is it 2 radical 3 over 2, negative? So negative 1, negative radical 3 is the x and y coordinates. Agree with that? Make sense? Okay, last one. Where's Austin? Baker. How did part C go? Okay. Can you just tell me about this? So what quadrant is 3 pi over 4 in? How about that? Where will the positive r point? Second, right? Halfway through the second. So that. Right there is 3 pi over 4, so I'll do it in blue. And then where am I going from there if I'm going to plot? Into which quadrant? Right, so then my red would be this way. Negative then would be, did I pick the wrong line? Sorry. And then I want to go how far? 3. Here's the point, negative 3, 3 pi over 4. And then you could use the formulas. You could be 3 times. Okay, so what about that? You can't do negative 3. Can you do that? Negative 3 times cosine 3 pi over 4. Does that work? Yeah, it works. And then negative 3 times sine 3 pi over 4. Yeah, it works. Which is negative 3 radical 2 over 2, negative 3 radical 2 over 2. But it should be positive. This is negative. That's negative, so this is positive. Cosine of 3 pi over 4 is negative, so negative times a negative gives a positive. And that's right, because it's positive x, negative y. I'll leave it up there if you want to ask on the way out.